Now let's talk about embedded steel. And the modeling of embedded steel is actually quite important. And sometimes companies don't do that and they prefer to do it in AutoCAD, and that's because they don't have the nice and good tools to do the modeling quickly. But it's very important to have it modeled because once you have it in there, then you can see any clashes with the rebars and stuff like that, and also the general quality and all your bill of quantities and all those will be much more accurate. And don't take it lightly, because it's not embedded steel is not like 5 or 10 or 15 pieces. You can have projects with hundreds and or thousands of embedded steel placed in your concrete. We just did a project on Comosys recently, in which the number of embedded steel plates was over 100,000. So you can well imagine what kind of pressure that would put on somebody who's doing that kind of stuff with AutoCAD. So how do we actually model embedded steel in Comosys? Well, it's very simple. All you do is you just set your work plane to the surface on which your embedded steel will eventually be located. And then if you've got the location of the embedded steel on that surface, or any snappable point, all you do is just go to your embedded steel command, select the origin, and select an X direction. You could have an inclined direction as well. You can select any direction basically for the X axis. And the moment you do that, you can right click and your embedded steel will be created immediately on that at that point. Now let's go inside the wall and see what it looks like from the inside. And I've opened the dialog box for the macro which created it. And as you can see, we've got so many options for the anchor bars. These are the ones you're seeing on the screen right now, even for anchor bolt placement, or like I said, the anchor bar placement, or shear keys if you want to place shear keys behind them, or if you want to place rag bolts. So all sorts of options. Let me go back to the anchor bar one. And over here you see that you have the choice of U type, or you can choose an RB type, for example, which is a different. You can change the angles of how they will be sticking out. You can go to the L type, for example, and you can once again give different angles, and you can also choose from these company databases. So, for example, if I choose this one over here, it will be a different one. And if I choose for different materials, you can have different ones. So let me go back to the preferences file folder over here, and go to the anchor bars, for example. And over here you can see that you can set up your company standards for the different types of bars at the back. And for each one, you can even have axial capacities of how much tensile forces they can resist. And then that'll be a quick reminder for you when you're designing the embedded steel. So it's very general the way it has been set up. Like I said, you can have all sorts of combinations of your bars, and even after you pull them from your company database, you can still go ahead and modify them for a particular project. So this one has a length of 600 millimeters, but I don't want it that long, so I can modify it there on the fly, and I can create a custom one there and then. And like I said, you can always in Comosys save them away as your company presets. So if I wanted a 16 anchor bolts instead, I would just load that, and my anchor bolts will be prepared. If I wanted 4 anchor bolts, I can give them different names and save them away for later use. If I wanted 4 rag bolts, for example, I could just call in the rag bolt option. If I wanted the say 4 tension bars along with 2 shear keys, I could have that as my embedded steel. So these options are very powerful. You can save hundreds of different types away, or however many you use in your company. And once you have them saved away, which is very easy, not time consuming at all, you can very quickly go through. All you need to do is just select points, like I just showed you. You put your work plane on the wall, or on the slab, or on the inclined wall, or wherever it is that you're working, and you just basically point and shoot. And it's as simple as that. And this is important, the fact that you can model embedded steel so quickly and so easily, because people avoid concrete 3D modeling because of things like this. because they find it too difficult or too time consuming to do modeling of this sort. But with Comosys, all these little things which add up, if you look at the whole picture, they have been put together in a very nice and convenient way. And the moment you're trained to do it, basically it doesn't take much time at all. One thing worth noting is that while we have a lot of control over the objects created by the embedded steel, we have complete control over the way the grid will be set out and the distances between these bars and all that. But whatever bar you choose, so for example, if we have whatever 8-10 bars over here, they'll all be the same from within the macro. But from outside the macro, you actually have individual control on every one of those bars. So I can just double click on any particular bar and I say this particular one I want to be of a length of 100. And that particular one will be shorter. And maybe I can do the same to this one as well, or the top two. So I can modify exactly according to what my requirements are, even if the macro doesn't really allow that, because I have individual control over the embedded elements once the macro has been done with them. And of course, like with everything in Comosys, if you were really pushed, you can do manual detailing and you can create any kind of an embedded steel which you wanted. We've done this is a very simple one. I remember doing an embedded steel which looked like a half a building because it was carrying almost 3,000 tons of tension. It was a huge bridge related project. But what I meant to say is that you can basically model anything you want inside Comosys. Now, there's a lot I haven't shown you yet, but we don't have time, so I'll have to just move on. So, for example, I haven't talked about how to create grout or how to create surface slopes if the surface has a slope, for example, how to create water stoppers, how to create individual covers if you needed to, how to create those hundreds of anchor bolt cutouts, which we saw in some of the models, maybe how to create flares. And I mean, there's a lot I haven't shown you, piles, for example, but you get the idea. The point is that you have to complete your model. The grout is important. The surface slope is important. If you don't do that, you will end up finishing your drawings in AutoCAD. You will start off in some 3D software, modeling software, but you'll end up in AutoCAD, and that's where you fall. That's where you make a mistake, and that's why your company never really gets going as far as concrete modeling is concerned, because half the stuff is done in a 3D modeling software, and the other half there might be minor things, but the fact is that they're not minor because whenever there are revisions, you need to go back to the same 2D drawings and AutoCAD. And once you start doing that, like I've mentioned earlier as well, you basically lose the game. It's not the way you're supposed to do 3D modeling. So the reason why I'm just going through these things one by one is to show you how and why Comosys will allow you to actually finish the model even when you have complicated industrial plants which need to be modeled.